The conversion of mass to moles is absolutely essential to chemistry. The reason being that mass is the property that is measured in laboratory. However, all of your calculations are going to depend on that quantity being converted to moles. This calculation for compounds is accomplished by first determining the formula weight and using the formula weight as a conversion factor. We're given the formula of methane. We see we have 1 atom of carbon. We add the mass of 1 atom of carbon, and we get this value from our periodic table. The mass of 1 atom of carbon to the mass of 4 atoms of hydrogen to get the formula weight. Now we can use this formula weight to write 2 separate conversion factors. Here are our 2 conversion factors. As always, we see that there are equivalent quantities in the numerator and the denominator. Saying we have 16.05 grams is equivalent to saying we have a mole of methane. A mole of methane is equivalent to 16.05 grams. Now we look at the measured number in the statement of our question. We want to convert 32 grams to moles. We will choose the conversion factor that cancels out units of grams and leaves us with units of moles. So the conversion factor we use is the one in which grams is in the denominator. 16.05 is in the denominator, and therefore that indicates division. We do the math, write down our calculator answer. Now we consider sig figs. 2 sig figs in this number. This number has 4 sig figs, so we're limited to 2 sig figs in our final answer. Our first number to be dropped is greater than 5, so we round up. We have our final answer of 2.0 moles. Again, we have the conversion between mass and moles. Nitrogen oxide has a formula weight of 30.01. We're going to use that as a conversion factor. We've written 2 different conversion factors based on the formula weight. Tells us that 30.01 grams of nitrogen monoxide is equivalent to a mole. A mole of nitrogen monoxide is equivalent to 30.01 grams. We go back to the measured number in the question, and we want to cancel out units of grams, so we're going to choose the conversion factor for which grams is in the denominator. This indicates that we have to divide this number by 30.01. We've written down our calculator answer. Now we'll go back and do sig figs. This number has 4 sig figs. This also has 4 sig figs, so we want 4 sig figs in our answer. The first number we drop is greater than 5, so we round up, and we get the answer 11.52 moles. Our third example of converting mass to moles, we know we're going to need the formula weight. So we determine the formula weight, this time of the compound glycerin. 3 carbons, 8 hydrogens, 3 oxygens. 3 carbons, 8 hydrogens, 3 oxygens. We have our formula weight. We've written down the measured number from the problem. We're going to multiply it by some conversion factor involving formula weight to get moles. We know we need to cancel out units of grams, so we're going to choose the conversion factor which has the units of grams in the denominator. We have our calculator answer written down. Go back and worry about sig figs. We have 2 sig figs, 4 sig figs, so our final answer is limited to 2 sig figs. The first number we drop is less than 5, so we just drop all of these numbers and write down our final answer. Calculations involving Avogadro's number. If we are dealing with elements, we know that a mole of a given element has Avogadro's number of atoms. We're going to use this identity to write a conversion factor. If we're dealing with a molecular compound, again, we know we need Avogadro's number to accomplish the conversion, and a mole is equivalent to Avogadro's number of molecules. If we're dealing with an ionic compound, we're dealing with formula units. 1 mole of an ionic compound contains Avogadro's number of formula units. In this first problem, we want to go from grams to atoms. So we're actually going to need two conversion factors. We can convert between grams to moles using, in this case, our atomic weight, since we're dealing with an element. If we were dealing with a compound, we'd use a formula weight. Then we could go from moles to atoms using Avogadro's number. So we start with our measured number that we're given in the statement of the problem, 9.58 grams of iron. We want to first convert to moles, then from moles to atoms. Two conversion factors obtained using the atomic weight of iron from the periodic table. We want to use the conversion factor that cancels out units of grams. Next, we want to choose the conversion factor that's going to cancel out units of moles. So we want moles in the denominator. We look at our setup and we see we do indeed cancel out units of grams and units of moles. Their surviving unit is unit of atoms, which is what we want. So we can do our math. Everything in the top indicates multiplication. The numbers in the denominators indicate division. So we write down our calculator answer, go back and worry about sig figs. 3, 4, 4 sig figs. So our final answer is limited to 3 sig figs. First number to be dropped is below 5, so we round down. This equals to 1.03 times 10 to the 24th atoms. Here we have a quick review problem. We want to go between moles and mass, so we're going to need the formula weight of nitrogen dioxide. We've determined our formula weight. There's 1 nitrogen atom. We add that to the mass of 2 oxygen atoms to get our formula weight. We choose the appropriate conversion factor based on the units we want to cancel. We want to cancel out moles, so we're going to choose the conversion factor with moles in the denominator. We can do our math, knowing that moles is going to cancel and units of grams is going to survive. We write down our calculator answer, determine we need 3 sig figs, and write down our final answer.